All right, folks. So welcome back to our AI agents, our second day for the AI agents course. What I would like to do today is keep it very hands-on. We will start with a quick recap of what we did on Monday. This is mostly to whet your recollection. It is in no means to give you an introduction to AI agents anymore. I'll just go through the slides so that we can touch upon the key highlights. So guys, may I request you one thing? Don't get onto the Wi-Fi, please. The reason for that is our Wi-Fi is not able to take the load of everybody. Right? So just follow along, and after that, I will take it from there. We have a GitHub, and you can we'll show you where the GitHub is in a little bit. You can download the code, but at that moment, perhaps you could connect. Because if we all connect to the Wi-Fi, what will happen is I'll lose connection. Okay? So please hold on a bit before we get into the Wi-Fi. All right, guys. So we'll start. So this is the schedule for today, or agenda. The first 15, 20 minutes, we'll recap what we did, the general introduction. The second 10 minutes, I'll remind you of the problem statement. Remember, today we will take a case study and use that case study as a sort of a kernel and say, how do you solve this problem using AI agents? And does it make sense to solve this problem using AI agents? And then we will get heavily into the code. Okay? When we go into the code, we'll again peel the onion layer by layer. First, we will do the prompts that define the role and goal of a agent, clarify the specialized role of agents. So we'll study the prompts and what makes for good prompts. Second layer, then we will talk about tools. We'll talk about something called Model Context Protocol. Some of you may be, anybody familiar with the term Model Context Protocol? It's basically the USB universal interface for agents and tools. And then we'll go look at the agents. And finally, we will, once we have done that, we ask this question. So how do you build a multi-agentic system and orchestrate the interaction? For that, we could have used any framework. And this code base, we kept it very framework-like. So that with very minor changes, you can make it work with Crew AI, you can make it work with Pydantic AI, you can make it work with Agno, or whichever framework that you like. We have to pick a framework. We picked LangGraph because LangGraph in enterprise has the greatest enterprise adoption at this moment. Right? Though in popular use, there are other frameworks that are low-code, no-code frameworks like N8N and LangFlow, etc., which are very popular. But no matter what your choice is, right, you can easily take this code base and maybe with the change of, excuse me, just one file or so, you can make it work with your framework. So we deliberately kept it very framework-like and focused on the agentic behavior itself. Are we together, guys? So with that, and again, as I said, today is the technical session. So the entire flavor of today's talk will be quite in contrast to our first day's talk. So what did we do the first day? Here's a quick recap. We talked about AI agents, the concept of AI agents. This is me. Or maybe I look a little bit younger than this now. This is our team. And Chanda is here. Chanda and I co-founded Support Vectors. He leads Support Vectors India. I lead Support Vectors US. We have a pretty distinguished faculty here, which has done amazing work in the industry, has all of these things. I suppose by the time you reach my age, everybody has this number of credentials. We do have. We have produced a lot of a very successful alumni pool. You can always tell a person is successful if he can sleep at his desk in the daytime. No, kidding. So we have a pretty distinguished faculty that helps in teaching this. And this is important for us when we teach. Again, just a quick spiel about Support Vectors. When we teach, we mean to teach. We are not doing the Udemy's or the Coursera's and those types. Teach you the easy stuff. But we don't believe that we take you around the mountain and say, okay, good hiking. We instead believe that we need to carry you to the top of the mountain. We are the Sherpas. We'll make sure you climb Mount Everest. We don't compromise on that. But we give you all the help necessary to take you there. From this place, a lot of successful things have come up. and I keep saying this, that after taking our boot camps, if you don't get a job, if you're looking for a job, if you're trying to transition into AI, if you don't get a job, let me know. You would become the first person not to do so. So we have a perfect record as of this moment, and 3,500 alumni have gone through it. So we would like to not break that record. So when we talk about enterprise AI, I talked about this, and before we go into agents, the three core pillars that makes for enterprise AI, whether you're talking of ChatGPT, Perplexity, Google, your internal RAG systems, or whatever it is, at the end of the day, they all look different. I sit here, Chandran, and we have our research group. We evaluate, we help a lot of startups. They come, they ask us for advice. They tell us, we got stuck here, we got stuck there. Is this the right approach? How do we build this? And they all build different things. But there is, they're very diverse, very different real world use cases they are solving. Right? And nevertheless, if you look at the technological core, in many, many ways, they all feel the same. They all have AI agents, they all have RAG, and they all require fine tuning and reinforcement learning of those agents. In fact, agents without fine tuning is an oxymoron, I believe. People who create agentic systems simply through prompts and using a framework, whichever framework, LangGraph, QA, etc., they leave a lot on the table. They create unreliable agentic systems that will fail. That is our core belief. We believe that if you create things, a good enterprise agentic system should be as reliable as a bridge. Right? People should cross it without thinking about it. So that's a core thing. Then we talked a little bit about the historical background of AI agents, and we talked about the fact that throughout cultures, we have always wanted that super efficient assistant for all of us, that given a goal, would autonomously reason and figure out what needs to be done. You tell it, go build me a castle. And it doesn't say, okay, now what do I do? First, do I go to the bricklayer or do I go to the beach to gather sand? What do I do? None. The Jenny from the magic lamp says, all right, you want a castle? And after a little while comes back and says, here's your castle. Right? That is the spirit of AI agents. People often ask, what's the difference between agent and programming? Agents are the antithesis of programming. Because programming means literally you say, do this, then do this, and if this, then do that, if else, and so on and so forth, and 10 times do this. Right? Programming is to program. There is no autonomy there. The program has no agency, no free will. On the other hand, the whole point of AI agents is you give it a goal and a role, and you ask the machine to reason it out how to achieve this goal and to use the appropriate tools and go achieve it. That is AI agents. This is a crucial point because often people wonder, what's the big deal about agents? And it is a big deal. Just like for 40 years or 50 years, software has dominated the technology landscape. Now, for the next few decades, it won't be programming of a hardwired programming, but it will be agentic systems that will dominate the world. A very lovely title from a research paper from NVIDIA was, and we covered it actually here in our weekly paper reading, was titled, "The Future is Agentic with Small Language Models." You couldn't agree more. The future truly is agentic. Corollary to that is your traditional software will vanish.
Just a clarification. When I read, articles and stuff, they kind of say if we find an agent, there is always some tool which is built, which is code, right? I mean,
certainly, very much so. So the whole thing is that agents doesn't mean that agents will be the only thing that is there. There will be code. There will be. So I'll give you an example. So the basic picture we talked about last time is, and again I'll remind you. So is that agent exists only in the context of an environment, right? So a Roomba without rooms to clean doesn't make sense, isn't it? So agents exist in the context of rooms that are dirty. This is the environment. Given that environment, a specific agent has a specific role and goal. Are we together? But how would it, sorry, I'm giving you talk. Yeah, so how would it go achieve its goal? See, it will use two things, sensors and actuators. Sensors to observe the environment. So think of a camera that's looking ahead. The camera has actual code in it, right? The sensor, the CMOS sensor, is receiving light, currents. It's becoming signal. That signal needs to be processed. That code will never go away. That programming will always remain. But and so that statement is that programming in itself will never go away. Right? What enterprise software will go away, so in the sense that you have. So there's a subtlety I mentioned. That programming will remain. Now this agent sees that, or you want to go on vacation to Hawaii, Maui, and say, the example we took, is it a good time? The agent says, okay, I need to search the web. The web search tool to figure out the weather, or calling the weather API, is code. That API itself is implemented as a REST endpoint over a database over the United States weather data, is code. There is absolutely no reasoning, no intelligence, no autonomy needed for that. And those things should be 100% implemented as pure programming deterministic code. Those are tools. But then the reasoning machine says, okay, the weather looks good. Let me check out the flights. Let me check out the hotel prices and so forth. For each of these, it uses tools. This is the actuator part of it. Gets the sensors, senses it, explores it, comes to the response from that. And it says, okay, now that I know the hotel prices, now that I know that you tend to like prices within this range, right? And temperature tolerances within this range, what does it all mean? It doesn't mean the definition. Does it fit this person's definition of good time? Isn't it? Of going to Maui, let's say. And if it does, then it can reason and tell you that. So when I say that the future is agentic, I don't mean that all programming will disappear. Right? For example, there are tools like grep. For example, if you work on Linux shell, you grep for things in files, which is never going to go away. You don't need an autonomous reasoner, isn't it? You need a regular expression parser, and that will forever remain programming. Right? And if now you look at enterprise software, what does enterprise software often entail? Most of you are doing enterprise programming. Is that true for most of you? If you are in the enterprise world doing coding, raise your hand. Right? Most of you are doing that. What does it mean? You use this API, that way, you create a workflow, you're putting Lego pieces together. Business rules. Business regulations and workflows together. A large part of enterprise software, especially software as a service mentality, is actually these workflows. The problem with these workflows has been always that product managers will come and say, we talk to our customers. These are the most high value use cases to do. You do that. And the moment you do that, the clients say, oh, but my problem is not solved, right? Because the number of use cases form a long, heavy tail. There's so many people who have this use cases that only they need. And you don't do that. If you are in the world of business intelligence, you know this. You create the so-called standard dashboard of standard reports. Anybody knows what I'm talking about? You ship with it. But if that's the only thing you ship with, your product will not sell. Why? Because every customer will need to create custom reports. Right? So what happens is that when you build software, whenever you build enterprise software, you not only build enterprise software, you actually build an engineering team with guaranteed job security now, so long as the software is there. Right? Because what happens is that as the software gets used, more and more use cases keep coming up, and this engineering team keeps making workflows after workflows after workflows, and the software begins to bloat. Right? And the point of agentic systems is this: don't do that. Instead, what you do is keep your tools, like keep your grep tool and your API tool and so forth. But this workflow kind of rule thinking that is the mass of business software, make it agentic. Which is why Salesforce CEO came out with a statement saying that, oh, SaaS is dead. I mean, in the traditional sense, it's going to be all agent. And in fact, they're toying with the idea of renaming the company to Agentforce. They actually have a product release called Agentforce now.
Right, yeah.
They use it for automation.
for automation and so on and so forth. So that's the thing. So I hope I clarified that, the distinction between the two. And so we continue that. I taught you a lot of the, and multi-agent systems and so forth. So the key takeaways are autonomous behavior, autonomous reasoning. What are the key ideas? If you ask people, what's the definition of agents? Everybody has a different definition. To the API aggregators, it's workflows. To the programmers always have a suspicious feeling that, hey, you know what? It's microservices and functions, fashionably dressed, isn't it? It's all hype.
Yeah.
And actually, are they right or wrong? They are partly right. I have quite often encountered agentic systems, and I scratch my head and think, why exactly did they make it using agents? The crucial word is autonomous reasoner. Do you really need in the mix of all of this an autonomous reasoner that will deal with a fluidly evolving environment? If you don't need that, don't use agents. Why? A well-written code, deterministic code, guaranteed output. Only two things can happen when you run the code. Either it will produce an output, which you expect it to produce, or it will have an error condition. It will have an exception and it will fault out. There is no third option, isn't it? With agentic reasoning, there's always a degree of latitude about what you get within the parameters of what you specify. You tell the Jenny, I need a castle with 10 rooms. You don't know which direction those rooms are facing unless you had told it beforehand, isn't it? So there's always a degree of latitude how an agent would want to solve the problem. And so you have to be very particular of constraining it with very clear specs. You must be remembering that when you do ChatGPT, you give it a complicated problem that's agentic. It would just immediately turn back to you and ask for clarifying questions. Anybody has had that experience? Yeah, it does that. Why? Because it wants to constrain the parameters in such a way that when it solves the problem, it is something that you would want. It is exactly what you wanted, right? But even in exactly what you wanted, there's still a degree of latitude of possibilities. That is agentic. So don't do agentic unless this is the litmus test, guys. Ask yourself, do you need an autonomous reasoner somewhere in the mix? If you don't need an autonomous reasoner, don't do AI agents. Right? Those problems don't need it. And if people are doing it, then they are actually putting truth behind their statements that their agentic systems are nothing but microservices and functions fashionably dressed. Right? Or they are just workflows. Right? So don't do that. And if you ask the researcher, this is obviously Richard Sutton, the father of this field, he would say learning entities in environments. Right? So anyway, there are many perspectives on agents. I won't go through this. The reactive systems view, according to it, even a thermostat is an AI agent. Many of us would say, that's taking it a bit too far, but right. Then you have the embodied intelligence perspective. Give agent a specific form. The form or structure and its engagement with the environment will sort of create emergent intelligence. Multi-agent system framework is the more typical way we think of AI agents. Then the tools perspective is lots of tools and one coordinator, which is a simplified architecture, one simple coordinator, having lots of tools to do everything. The trouble with it is that the tools and for example, with MCP, it becomes really possible. And the only problem with that is when the problem gets complex and you have lots of tools with overlapping definition, then the single agent may not be intelligent enough to know to use this tool or this tool. Right? So it gets more complicated. The theory of AI agents, as we said last time, goes back decades. It's not something that sprang up just last year or this year. It goes back decades. I know that because when the distributed AI theory was coming up in the late 80s, right? The steam engines were still around, and I wrote one, the last of the steam engines. So that's why I put this picture that don't be deceived that it's something that was cooked up yesterday. Nevertheless, see, when you think of agents as autonomous reasoners engaging with the environment through tools, environments existed, tools existed. What was missing in the whole agentic theory that was developing over the decades was the autonomous reasoner. When the LLM came about, people said, oh, the LLM is able to reason a little bit. So they saw the potential that you could build agentic systems. You must have noticed that agentic systems literally are co-evolved with the release of LLMs, ChatGPT and so forth. and they became, except that they were very weak reasoners. A true reasoning LLMs came only since February of 2025, right? At least now in the closed world, commercial world, OpenAI had its strawberry model, but they never revealed the details of it. And in February 2025, in the open source world, DeepSeek R1 was released, which completely laid out how to build reasoning machines, how to induce reasoning ability in machines, which was a remarkable breakthrough. And after that breakthrough, now today, all the pieces have fallen in place, which is why today you can honestly say that AI agents are not hype. The future is agentic, right? Is the right way to go about building enterprise software, which doesn't mean that every software needs to be done with agents, but at least a large part of the software can be where you need reasoning. Instead of baking it into code, programming it in, let an agent discover it. Because it will do the thinking dynamically, which you as a programmer would do anyway, and bake into code. Example we gave is going to MOI, the agent. What can you do? So let's go through this cycle. Observe, reason, and act. The environment is there. User statement lands there. The statement is it a good time to visit MOI? So agent observes that statement. That is observation, isn't it? What does it reason? It reasons, to do that, I need to, actually, again, the typo is still there. I need to reason. It will reason and conclude, I need to find out the weather in MOI. I need to know the flight cost and the hotel cost, isn't it? Because it knows that the user considers it to be a good time only when it is not snowing or extremely hot. These are the weather parameters. Or there's no hurricane, for example. So what will it do? Based on that reasoning, what would be the action it would take? It would look around for a weather tool, finds a weather tool, which would be a weather API, government weather API. It will invoke that tool. What will that tool do? It will produce a result, weather result, that has mutated the environment. Now the environment contains the user question, as well as extra information, the weather, isn't it? Likewise, it will invoke the flight cost tool and come up with certain flight costs. Environment now is again mutated. It has more information. Likewise for hotel prices. The environment has more information, the hotel prices. Do you see that, guys? So what you have gone through one cycle. What has the agent done? It has observed, reasoned, acted, and the end result is the environment is in a state, would you agree, that it is now closer to the goal? Not yet at the goal, closer to the goal. You're in a much better situation to answer the user's question, right? And then what will the user do? User will then observe that environment again, all those results, think about it, know the user's needs, and then come up with a recommendation. Does that make sense? Right? And that is agentic reasoning. And that is quintessential agentic reasoning the way you want it, because this is a problem that admits certain latitude. You're letting the machine recommend to you the flight by Hawaiian Airlines versus flight by, I don't know, by Delta Airlines, isn't it? It can decide which are the lower price fares. It can suggest to you good hotels where there is availability. And the latitude, the autonomy that you gave to the agent comes in useful. And you come back and you say, okay, that looks like a good plan. I think I'll go to MOI. So far, so good, guys? Yeah. So this is it. So just to summarize, and now this time we have to get immediately to practicals. Remember this word, guys. If there's nothing, agent comes from agencies. It implies agency. There is no agency without the ability to autonomously reason and act. So if you just hardwire a workflow or script a program, you have taken agency away from it, right? And therefore it's not agent. And this is important because when you start actually writing AI agents, quite often what will happen is, and this is a little bit of my own journey of learning. I have been studying mathematically all of this agentic distributed AI for decades now. I got into AI, fortunately, many decades ago. I used to do machine learning, and even computer scientists used to think I'm doing a collaboration with mechanical engineering because it has the word machine in it. right? So those times have obviously changed now. But today, when I started doing agents, especially with LLMs, I couldn't help observing that my code is like, instead of writing in C or Java, C++ or Java or Python, I just happened to be writing it in English. I was giving very precise instructions, do this and then do that and do that. Many of you have had the experience of either being the child of a helicopter parent or more likely being one yourself. That's what you do, right? Do this, exactly. There's no autonomy. You take the agency away from the child, right? I was literally doing that because decades of programming had wired me into that thing and give very precise instructions. Be careful. Did you consider this and this corner case? Did you consider that corner case? Everything was baked into English, right? It gives color to the word. English is the hottest programming language, literally, right? I was doing that. It took me literally 3 months to gradually snap out of it. Suddenly, to create, be finally able to create AI agents that truly had agency. And that's the reason I'm mentioning this thing. So key takeaway is autonomy means more than functions and microservices. Reasoning connects observation to actions towards a goal. Tools empower both observations and actions, right? So it is important. Why agents? I won't go into this because we have been through that. This rubric is important. Agentic systems have planning, they have task decomposition into simpler pieces to achieve coordination, collaboration, critique, and reflection. Why? Because language models are very good. They generate a response, but they're even better at telling you the response they generated, whether it's good or bad. They're actually very good judges of their own actions. So critique, memory streams you need, tools, of course, you need. Right? Oh, guys, by the way, this slide deck will be public. It will be on the GitHub. And we have a public GitHub that we'll point out to you in our support vectors GitHub. This project is, and all the code base and all the artifacts are already there. Right? So you don't have to necessarily take, if you like to take pictures, but of course, do that. But remember that you also get an open GitHub. Right? So everything that we are showing you is yours. And by the way, also we have put it under Apache license, the code base, which means you can take it and do whatever you can, except for one thing. Don't sue us if it doesn't work. So now, the whole renaissance of AI agents, what makes AI agents powerful today? First is prompting. One pillar is prompting. Prompting is often undervalued, right? Prompting is actually hard. Writing good prompts takes a lot of learning to do. I remember I was just sitting here, literally in this chair, 2 years ago, and one person came out, one engineer came to me, and he was quite mad. He said, "Did you look at this? Anthropic just released a job profile, right? Posting, job opening, and they are offering 350K base for a prompt engineer, right?" This was 2 years ago, right? And he was like, "I am an engineer with so many decades of programming experience, and I don't make this. This is so unfair."
Yeah,
Right?
right.
But actually, it's not unfair because engineers are terrible communicators. Right? Ever look at the documentation you write in your own code?
Right.
Right? And you will see how bad it is. So, whereas prompt engineering is all about very efficient communication with a person about whom you know nothing. Right? You have to educate the person in the prompt about your context, about your problem domain. Sort of ramp that person up and then give it a problem to solve. And that's communication, efficient communication. It's really hard to write good prompts. Right? And there's a statement in psychology. It's like arrogance through trivialization. You think writing English is trivial, therefore you're arrogant about it. We engineers should, be paid more. Of course. Right? But likewise, I'm sure that if you meet donkeys, they would insist that there is nothing so superior in the world as a good brain. Right? So we all, whatever we are good at, we definitely value it a lot more. right? And that is always true. And the reason I'm putting it in such obnoxious terms for you is just to instill the point that prompting, guys, don't trivialize it. Don't be arrogant about it. Give it a lot of attention, and we'll do that in code. Once you have written the best prompt that you can through prompt engine, nevertheless, apply further techniques. There's a technique called prompt optimization that helps you discover the best prompt for that particular LLM and version for that problem, for that given task. You learn all of these things in the agents course, that bootcamp, if you do come to it, DSPY and all of that. Orchestration, you have frameworks like LangGraph, Creo AI, etc., etc. We'll be using it. Specialization of agents is important. Why? Because you want a surgeon to do surgery. You want the electrician to do electrical work in the hospital. You want the civil engineer to build the hospital. You don't want to have one generalist do all of it. Right? So a team. Now, there's also the whole point that the collaboration in the team can be enforced through a form of reinforcement learning called a multi-agent reinforcement learning. That's a little bit hard. There are technical reasons for it. Why? Because of this problem of non-stationarity. Means a Roomba is trying to decide, oh, I see dirt, I should go clean it. But between it seeing and actuating, deciding to do that action, another Roomba might have already done that, come into the way, and all you do is end up bumping into that Roomba, right? And you can end up in a situation like you see here, right? Dirty floor, and all of the Roombas are just banging into each other. That's a problem of multi-agent reinforcement learning. Recent research and breakthroughs have made it far more efficient. A lot of new progress is happening. The world is quietly, one of the biggest things that you will see, the renaissance of ambient agents. What are these ambient agents? They don't wait for your command. They're quietly waiting and watching. Very much like the golden retriever. I used to have a golden retriever. She looked like this. And she would sleep next to me. And she would be observing the environment. What was the environment? My breathing patterns and the outside skylight from the window. She knew when it was morning, the earliest dawn, and even before I knew that I was awake, by changes in my breathing pattern, she knew, and she would be all over me the moment I woke up, right? Because she wanted to go out. And so that is the metaphor for an ambient agent. An ambient agent observes the environment passively, looks for a specific signal, and then reacts to that signal. My belief is that far more than actively engaged agents like the one that, like ChatGPT, etc., in the world, you will have 1,000 to 1 ambient agents, 1,000 times more ambient agents who will bring efficiencies in our life. Right? Look, for example, the domain of HR, for example. In a way, they are human ambient agents in every organization. What's the purpose of HR professions? They just make sure that everything runs smoothly. Right? People stay happy, their onboarding, their sickness, their leave, all of their problems are taken care of. Right? Organizations without HR are dysfunctional organizations. In a way, they are human ambient agents. In the same way, you will see that more and more in environments all around us, ambient agents will come about. Industrial, physical AI is the next big thing. And the CEO of NVIDIA makes a really big deal about it. That when you put reasoning LLMs and robotics together, you have an explosive combination, the physical AI robots. It is happening in industrial countries where manufacturing is a big deal. South Korea, China, Japan, Taiwan. Yes, go ahead.
Does agents hallucinate?
To the extent that there's a reasoning LLM there, yes, they can hallucinate. And so it's a good segue. So what they do is they create, for the factory floor, they create a digital twin. Something goes wrong here, it goes wrong in the digital world, virtual world. What happens is the LLM is reasoning in the physical world. The robot is in the, the LLM is reasoning in the virtual world. Yeah. The robot exists in the physical world, right? Once the LLM, because the LLMs can hallucinate and imagine that there is a path through the wall, there may not be. Once you establish the solution that the LLM has come up to works, because you have made it work in the virtual twin world, then you propagate it. And so you protect against hallucinatory disasters. In the real world, the robot will do only what is verified as correct action. And that is physical AI. Because of this, the manufacturing has transformed completely. Today, the old notion, 20th century notion of a factory used to be armies, vast armies of people coming, parking lots full with cars, people getting out of their cars and going to the factory to work. The 21st century notion of a factory is for miles, nobody is there to be seen. The factory is completely empty, completely run by robots. And in fact, these are called dark factories for a reason, because there is no reason to even have a bulb there, to have a light there. They're literally dark factories. This is a reality today. It's not a science fiction for tomorrow. It's a reality today, the 21st century factories. So use of this is heavy. Now, we talked about teams that AI agents are good when they have teams, they have emergent behavior, specialization. Shapely, we drilled quite a bit about Shapely. At the end of the day, a good multi-agent system is closely parallels a good surgery operating theater. Right? If you look at good theaters, good surgeons who have a very high success rate, you will notice in their team flawless collaboration. They stretch their hand and the assistant knows what to place in their hand at that moment in surgery. Right? That is important. And that is a multi-agent system. Right? So we talked about this paper, generative AI, just to remind you, researchers created these personalities, AI agents, which had a role. One was a chemist, one was a politician, one was a college student, one was a husband, one was a father, one was this and that. And they put it in an environment, it was a small village with school, library, this and that. And what they noticed is spontaneous behavior come out. This paper shook the world. It is the second most quoted paper in the world of AI agents, 3,000 citations, but not from AI. The most cited paper is Reason and Act, which has about 5,000 citations. But all the citations come from the field of AI. This paper, which is the second most cited paper, this research came out in spring of 2023, right after ChatGPT came out. And it has close to 3,000 citations, but a lot of the citations come actually from other disciplines like social dynamics and anthropology and so on and so forth. Remarkable thing is those AI agents began to mimic human behavior. The idea was they gossiped, they talked, they changed their mind. One person didn't want to vote for a candidate for mayor, but then after talking to other people, changed his mind. The idea was dropped that there's going to be a Valentine's Day. Spontaneously, they said, let's have a party, Valentine's Day party. Then what happened? They started dating each other. They found their dates, came to the party in an organized way, and there was actual Valentine's Day party. Can you imagine ever being able to program all of this? Impossible. So this is emergent behavior, right, in machines. So anyway, we will go quickly through all of this. Where are they used? Well, of course, as I said, don't use it for travel agency. Don't make travel agents out of it. You'll pay too much money, right, if you do that. Well, I won't go through the use case, but now what I would do is very quickly, I will end the summary. And is this a good recollection of what we did last time? Yeah. Right. So now let's come to the use case. So, and the position use case we took is in the field of HR, in people operations, one of the most tedious things, all of you are managers or work for companies and you have managers. Don't you go through the process of writing self-reviews and reading other people's self-reviews during the performance cycle? The self-reviews are notoriously subjective. Some people write 3 lines self-reviews. Some people write entire novels, right? Some can say a lot without actually saying anything quantitative, right? Without saying, I finished this project, or it's 100% done, or I reduced the latency from this to this. No quantitative details, no KPIs, right? And some are packaged in a condensed way with all sorts of KPIs. So there's a wide latitude on how self-reviews are written. And so we took this little project, agentic project. Suppose we create this agentic app. Its job is this. It will, now people have typos, especially we are immigrants, a lot of us, and our English is not flawless, right? People can always, natives, people born in US, can always spot that if they can't spot it from the color of our skin and our accent, they can immediately spot it in our writing because it would be infused with typos, right? And grammatical and oddities. So what we will do is, and the last thing you want as a HR person is, A brilliant person who has done brilliant work to be penalized, or just because the language was not fluently done. So what we will do is we'll take such a self-review and clean it out automatically without losing any of the signal. Rewrite it, fixing all the typos. Those of you who are familiar with Grammarly, imagine just putting it through Grammarly. Something like that. One agent does the same thing that in effect Grammarly does. Cleans out the language. Are we together, guys?
Right.
Then the second thing is when you get a novel for a self-review, don't you long, and many of you have been, obviously, I can see many of you are senior and you have teams under you. You dread reading those and missing important signals. So two things are essential. Can an AI agent summarize the text without losing any of the crucial signals, without losing any of the crucial achievements of the employee? That would be wonderful, isn't it? So you read a much more condensed version rather than a digressive version. Third thing we took is, can we extract key achievements, the most important achievement first, from the running text as a table of achievements? That would be valuable. Would you agree, guys? Lastly, and this is more important, can we take, actually, and for the employee, by the way, who's writing a review, they may also need a feedback. Did I write a good review? You have this doubt. So we will create a little tool, one agent at the service of the employee telling, hey, you need to improve your self-review. These are the deficiencies in your self-review. Why don't you go fix it and help the person write a better self-review, right? And lastly, see, you may have achieved something to perfection, but it may be the most trivial project, too easy, and of very little impact to the organization, right? So going back to the concept of Shapley value, you realize that if you have done very well something that was a minor achievement, you should be rewarded less than somebody who has done very well something that for the company was a mission critical achievement. Does that make common sense, guys? So does it not make sense that we take each achievement of an employee and contextualize it in the backdrop of the project definition? So there is a thing called RAG, retrieval augmented generation. So we'll use that to go to the database of projects, pull the right project that this thing refers to, this achievement pertains to, and reflect upon it, because that is again a reasoning task. How much does this achievement mean in the broader goal of this project, right? Is this a significant achievement? Is it a critical contribution? Is it a minor contribution to achieving that larger goal? Are we together? Right? Wouldn't that be useful? And at the end of it, as a manager, and especially as an HR professional, you would want to see those answers. And so we will build it, we will showcase you a demo, a system that does all of this. And the thing that you will see is as we walk through the code, it is literally achievable. All of this thing looks very complicated, right? You would think that, oh my God, this is practically a startup, right? And we need to give a year. Let's go to the VC pitch and get $5 million funding, right? And the thing is, do get your $5 million funding, but we are going to contend that you can build this agentic system in 2-3 days. And we will build it. I'll walk you through this. Fair enough, guys? Okay, so let's look at the demo. To see the demo, Chandra, would you like to bring up the demo?
Yeah, I'm doing.
We saw the demo last time, but this is to whet your recollection bit.
You seeing my
So
screen?
again, yeah, we are seeing this. Chandra, could you please maximize the browser? Yes. So guys, this is just to remind you. We will take 2 cases. And by the way, just for the sake of efficiency, we have run the agentic system to produce the results, right? Here, what we will do is we'll take 2 polar opposite employees. One employee writes a very perfunctory little self-review, 3-4 lines, which has hardly any details. And the second employee writes a good review, right? This is the review, which is If you read the second review, guys, you notice that it is infused with quantitative details. Just glance at it. It talks about 186 tests, and the test coverage went from 22% to 81%, and this and latency fell from this, cluster hours went from this to this, right? So one review is filled with KPIs, key performance metrics. The other review of the employee is just a running 2-3 line statement. And we will see how the system, how an agent system can help that. So the first thing we do is, see, the text may have typos. The first thing we would like to do is to rationalize the text. So let's show the rationalized text for the both of these. So this is simple, the text, but for the other employee who has done incredible work, but presumably her English was probably not native English. And so there are grammatical errors and minor typos and spelling errors and so forth. So when you rationalize the text, it just, I hope, feels more readable, more professional, isn't it? It just rationalizes the text. The second thing we do is we summarize it. When you get a lot of text, wouldn't it be nice if we could somehow summarize without losing the signals? Yeah, without losing the key signals. That is hard. See, you can ask a ChatGPT, hey, could you please summarize this essay or something to me? It will summarize it. But we are doing a more specific task. We are saying this is self-review. This represents some person's one whole year of work. So be careful when you summarize and don't lose any of the key signals. Okay. So you do that. And if you look at the summary, I hope you would agree that none of the key signals are missed. It talks about Debezium and Kafka, and 72 hours went down, 7 hours to 20 minute execution went down to 1 hour, amazing achievement and so forth. Right? Preserves the signal. Then you go to a word cloud, which is straightforward, to get a gut feeling of what this user has done. And then let's go to the achievement. Right? So we'll start with the achievement of the poor user, the bad review. So when you look at the achievement of the bad review, observe that, see, when you look at the text is a running text. What you want to do is understand the thing and create a crisp title to that achievement, right? And figure out what is the outcome of that work that the user did and what did it have impact on, delivery area, and then relate it back to the project that it was about. Can you imagine an agentic system to reason and do all of this? Because that is what you would be doing sitting there. Let's go to the good review. And in the good review, let's see how well it comes out. Extracted key achievements. By the way, if you are in HR or if you read other people's self-review, your team people under you, this is what you do. You just take a paper and pencil and keep extracting key achievements so that you can compare employee to employee and stack rank and do things like that. So this is what it is doing. It pulls out key achievements. It tells which area it impacted. What are the key metrics? 7 hour, 20 minutes became 1 hour. 1 hour, 24 hours went down to 2 hours. P95, 3.8 became 0.6, and so on and so forth. Infused with specific details, and contribution is critical. This employee seems to have made really big contribution. And then finally, as a feedback to the employee, let's go to the radar graph.
Question.
Yes.
Can we not get the achievements without word cloud? Why do we have to do word cloud?
No, word cloud has nothing to do with it. It's just a gut feeling. It's an old thing.
Yeah.
Just to get a gut feeling of what
Just was wondering, like, should we even do word cloud?
You don't have to. It was just, for us, it was just, the reason is we needed to create easy tools, MCP tools for you, so that, when you are coding and learning agents, you say that, okay, I can create an MCP tool that can create word cloud. That's an easy one for me. Right?
I was wondering,
so that's why we threw it into this. So if you want to, as you learn this, start with the MCP tool that makes word cloud, right? Because that's an easy one. So here it is. As you can see, the quality of this self-review is pretty good. It emphasizes outcomes over activities, quantitative and specificity is high, clarity and coherence is high, conciseness, no. This user does ramble a little bit, The review could be more tight, and then ownership and leadership aspects are well covered. In contrast, let's go to that other review and see what the AI is giving feedback to that employee. Almost nothing is done properly, isn't it? Right. So if you look at the left sidebar bottom, would you not let an AI agent help the user employee out by saying, hey, there are too few achievements found. Right? Are you trying to get laid off? Right. So elaborate on the details and add measurable achievements, then try again. Does it make sense? Right? So we are going to build this. Now the question is, I'll give you a 5-minute break, and then I'll just let you think about how exactly would you go about doing it. Right? And then we will continue and walk through the solution for it. So that now when you see the code, I hope the context will be clear in your mind. Do we agree, guys?
Yeah.
Right? Okay, it's 8:03. Let's meet at 8:15. Right? And then get started. We showed the product already, isn't it, guys? So I'm going to now show you the code from my coding laptop.
Can you share the link to download from
Oh,
GitHub
yes. Can I share the link to download?
in the chat so that
Yes. Chandra,
I can put it. The GitHub, right?
That is right.
yes.
Yeah, I'll put it.
I can download.
And by the way, it is as simple as this GitHub support vectors metamorphosis. So this GitHub is public, guys. Go pull it, have fun, play with it. Right? It is. We literally put it under Apache 2 license. Do with it whatever you want. Incorporate it into your products if you want. Incorporate sections of this code into your product if you want. It's totally yours. So now, instead of showing it to you from here, what I will do is, actually, maybe I can just show it to you. So we'll peel the onion layer by layer. Right? We'll first go to prompts and think about this. See, guys, we looked at all of those functionalities. Something that summarizes the text but doesn't lose the signal. Right? It is an important agent, important functionality. It needs reasoning. But is it a reusable functionality? Will other workflows need it? Possibly, isn't it? When you come across some functionality, even if it uses reasoning, intelligence, but needs to be a reusable component, make it as a tool, because a tool, agent can also be a tool. Are we together? And in particular, we'll make it into a MCP tool. Right? So now let's look at one. So there are a lot of these prompts, and the point that I wanted to make is creating prompts is not trivial. It takes effort. Do it well. See, to summarize text, what would you do? You would go to Notebook LM, or you would go to ChatGPT and say, here's the text, here's the PDF, summarize it. Do we do that? Many of us?
Yeah.
Yes.
Can you explain the design, how this is to be designed? Because
Oh, yes.
generally we are going to prompt, but is that approach you will always take? No, right?
No. So here is how it is. Sorry, I did it last time, so I want to repeat it. Thanks for reminding me of that. Let me repeat it. Okay. See, guys, let's take the simplest word. Remember we had in the UI the word cloud. Why did I plant a word cloud? It's not a very useful functionality, but for teaching purposes, it's great because it's a very simple tool. Does it require intelligence? No. Word cloud. So word cloud as a functionality should it be an agent or a tool? Just tool. And we will make it an MCP tool. Isn't it? Let's look at the next function. So I'm taking you through the design process that you asked for. Let's now look at the summarizer. See, to summarize a text without losing signal, does it require intelligence? It requires deep reasoning ability. Yeah. Right? So summarizer, so the opposite of that is the joke. When speed reading used to be the fashion, one guy said, I read War and Peace in 20 minutes. And then he was asked, okay, what was it about? It was about Napoleonic War. He missed the whole real context, which is the human condition and how it responds to the adversities of war. Right? So that is not the summarizer you want. You want a summarizer that doesn't miss the main point. So summarizer, what should we make it? It is a reasoning entity. It looks tempting to make it into an agent, right? Can somebody argue against that? No, you can argue and say, well, it is reusable component. Other workflows may need it. Other applications in your organization may need an intelligent summarizer. Isn't it, guys? So therefore, what you do is you make it into an MCP tool, because then what happens is, architecturally speaking, you can deploy it, for example, on a Ray server, Ray cluster, away from your application, agentic app. And your agentic app will call that service, very much like you call REST services. We'll call this MCP tool, word cloud, summarizer. What's the advantage? If summarizer is getting very busy traffic, a good Ray distributed system, because this is a distributed system, it can scale it out. It can start spinning up multiple instances of the model, isn't it? On many, many GPUs. Whatever functionality gets load, it can automatically, elastically start scaling it up. That's one advantage of making things into tools, right? And therefore, it is a good candidate for a MCP tool. Guys, are we getting the point? Right? That is it. Now let's take the, so what we did is we made this, I think, the rationalizer, text rationalizer, just removes minor grammatical errors, preserves the structure of the,
Question.
yes.
You have been referring to only GPUs. Are CPUs dead?
Oh, CPUs are long dead.
Wake up. Wake up.
Have you seen Intel stock price? I've been holding on to Intel. So I'm one of those people who believes that you should only buy stocks and never sell it. But I regret it every time I look at the Intel graph. In 25 years, it has gone steadily up and then steadily down.
Drop it.
So if you need any other proof to say CPUs are dead, that isn't. Right? Okay. So you look at the rationalizer. To rationalize text, by the way, jokes apart, you can do it on a CPU. Anything you do on the GPU, you can do on the CPU. But it is literally like sitting next to a glacier and watching it melt. Right? It's very, very, very slow. I'm not talking about twice slow, thrice slow. I'm talking about 10,000 times slower. Right? You don't want to do that, right? It is like something finishing in a day and something not finishing in your lifetime, right? So there's a wonderful book, The Hitchhiker's Guide to the Universe. They build a massive supercomputer, and then the people. How many of you have read The Hitchhiker's Guide to the Universe? It's a lovely book. Yeah, you do that. And then they ask that machine, great machine, tell us what is the meaning of life. And the machine goes into a deep think, very much like these new models go into deep think. It goes into deep think, centuries pass, but the generations remember that a deep question has been asked. One day it will come up with an answer.
Really?
Yeah. And many, many generations later, the answer is there. So everybody goes looking for that answer. And the answer is 42 in that story. Right? So that is why actually you must see in computer science in our field, whenever have you seen that random number generators are often initialized 42? It's an allusion to the story. So anyway, so when you use the CPU,
Yes, Google, they will answer for
Yes.
you based on the Isaac.
exactly. So when you start using the CPU, you have to write it in your will for your children that remember the answer will come. All right. So let's go to the rationalizer now. Rationalizer just cleans up the minor blemishes in the language. It needs reasoning, but does it need big reasoning, big brains to do that? No. So let me just call it small language model. SLM is a perfect use case. I would even call it a tiny model is good enough for it. Rationalizer. Once again, a functionality that is reusable, Legal may also want to clean up the language, fix the grammar, fix the typos. This is again a good tool, isn't it? Now let's come to another core functionality. You extract key achievements from the self-review. That is very specific to the HR operation of understanding employee self-reviews, isn't it? That you want to make purely as an agent, isn't it? Key achievement extractor will make it into an agent. Then you may have done an amazing job, but how relevant is that job to the organization? That you can find out by looking up the projects. There will be a vast corpus of projects and their definition somewhere in the database or in some documents. That knowledge base, if you want to access, what is that? It's a RAG, retrieval augmented generation, isn't it? That's a search. That search itself is a tool, it's a node. You search, isn't it? So this is one of the interesting things. When you do agentic thinking, the entire RAG system becomes to you a tool, right? In your larger workflow, you go and get that. And so there will be RAG over project documents. And finally, you have an evaluator, the biggest intelligence. This guy achieved this, we found out. What does it mean broadly in the context of the project? Is it high impact? Is the project itself high impact? If this project is mission critical to the company and the user has made significant contributions or critical contributions to this project, you realize that this is a singular achievement, right, by this employee, and it needs to be recognized. You want that to be contextualization to be there. So the entity that it needs to be a reasoning model, isn't it? When you use a reasoning model, will you use the tiniest brain or would you use a substantive brain? You have only two choices. Tiny brains won't work. You can go get GPT-5 Pro, that's one. Or the alternative is, don't do that. Take a small language model, but take it through reinforcement learning and make it really smart at doing the job. When you take a small language model and take it through reinforcement learning, believe it or not, and that's the big message of agentic systems, it will outperform the GPT-5. Only for this task. But that is the point of agents. You create specialized entity, which are geniuses at one task. With small brains, they can do that. Right?
Can
Go
I
ahead.
clarify something on that RAG? I mean, so RAG, you need to create the vector database and
Everything, yes. And we'll take it to that.
So when we say RAG here, is it just the retrieval part? That
No,
we meant?
the generator part also.
Oh, well,
Because that is it. That is the one, the LLM there is saying, okay, in view of this achievement and the documents that you search for, retrieve for, give me the significance of this achievement. Contextualize this achievement. You see that, right? You see, it's a very powerful
but
use of
it's a
that.
staging, right? I mean, the data is staged in vector database.
Absolutely.
So that's a one-time thing.
One-time thing, yes.
But so as part of this, you don't have to do it, right? That's something you can do separately.
Separately, yeah.
Right?
Yeah.
And
So
the
the idea
retrieve-
is that that RAG subsystem, you build it, but the retrieval part, you build it. But the generation part, you need the prompt because it is specific to this application, isn't it? Because what you're asking it to do is to contextualize it. Yeah. Typical RAG gets user input. Here, you're not giving user input. You're giving it an achievement that an AI found in the review, right? That is it. So, guys, this is it. Now let's go. So that evaluator, that smart evaluator, which will use RAG and comes up with an answer, is another big piece of intelligence. Go ahead. Yes, we are not just building it. We have built it and we'll show you now. Right? So, because the time is of the, we can't do that. See, guys, it's a 2-3 day effort, 5 days effort, 2-3 days effort to build it, but we will walk you through the solution. How about that?
Right.
The whole solution. Yeah. You take the solution, you run it, it's yours.
The code is available.
It's already available, publicly available on GitHub. Right. So, guys, from this you can take useful blocks that may mean something to you. The summarizer, the this, the that. You can use it in your other projects. Now, what I'm going to do is
could you explain that SLM part? Is
A
it-
small language model.
Yeah.
Let's say, I want to do rationalization of text, remove minor linguistic blemishes. Do you really need a 1 trillion parameter model, or just 1 billion parameter model is enough?
Is there a base model available for you, for us to consume? or-
Oh, yes, yes, everything is publicly available.
Okay. Then
See, the constraint is the hardware, right? Fortunately, the research community has been extraordinarily open. All the models are available freely.
In that context, can you also explain distillation of, let's say, 7 billion LLM down to
Down
1
to that.
billion SLM?
See, distillation, so this is a little bit of a digression, but I will do that. See, what happens typically is distillation was a process discovered by Sir Geoffrey Hinton. What he found is that, let's say that you have this data. You train a big model on the data and you train a small model on the data. There is something called the neural scaling laws. By the way, we cover all of this in detail. But neural scaling laws have a precise mathematical expression saying, if you want to learn from this size data, this is the optimal size of brain that you can train, parameters model that you can train. And to train it, this is the compute you need, compute budget you need, these many cycles of compute you need, right? Those are precise. And there's a concept of chinchilla optimal. What's the optimal mix of that? Compute for this data set, for model size and this. So obviously the big model wins. Now you take a small model and you train the small model on the same data. It is not chinchilla optimal. It won't be able to, it's a small brain, right? It won't be, no matter how much you sing to a mouse, it simply won't learn any poetry, right? So this won't learn. The evidence it doesn't. But one of the interesting, remarkable things we have found is you tell the mouse, or you tell the small brain, don't just learn from the data. Actually, for this input, you don't try to guess what the output would be. You try to guess what the master, the bigger model would say. Imitate the master. When you imitate the master and you become good at imitating the master, it's called distillation. And by the way, distillation is something you all know from a fact. When I was a kid, I used to love painting. So I joined a great master of painting. He came from the London School of Fine Arts, which at that time I didn't know is really the best one. So he had standards way up there, right? And I thought, I'm good at, I love painting, I'll join his class. And you know what he did? First month, he just put a few pots and things and a source of light and made us do the still life of those pots and tumbler and glass, etc. to perfection. We kept on doing this over and over again. So we said, okay, now maybe we'll move to something better. Then he says, which master do you like? I said, I love Rembrandt. He says, oh, you love Rembrandt. Very good. Gave me a book of Rembrandt's painting. He says, pick one. Which one do you like best? And I didn't know that it was a trap. I picked one. And then for the next whole 3 months, all I did is painted that portrait over and over and over again. That is distillation. That's how you become a great painter, right? In practical life, pair programming we do in software. What is it? You sit next to a master of programming in the workplace. What is the junior person doing in pair programming?
learning.
Learning. That learning is distillation, right? You see, that's very efficient learning. So that's distillation. So a smaller model can learn better by imitating the master. Okay, guys. So now let's go to the code. Now, so guys, are we done with the design? You get a general sense. Let's start with I will go to the prompt. Just the summarizer prompt. See, guys, when you do a summarizer prompt, you might say, well, that's very easy. Hey, machine, can you please summarize this text? That's what most of you do, isn't it? So it may come as a surprise that if you look at this text, it is a rather long text for such a simple task. And this is one of the first lessons you learn with prompting, that the first prerequisite to a good agentic system, it's a necessary but not sufficient condition. Remember, guys, necessary but not sufficient. Necessary condition is that your prompt must be perfect. Otherwise, everything is lost. In itself, it may not be sufficient to produce a reliable agentic system, but it is certainly necessary. There are many ways of writing good prompts. One way is the so-called CoStar thing. Singapore government sat down one day, called a committee and said, what's the best way to write prompts? And they all said, okay, we'll think. And they thought and thought and thought, and they came up with this template. The proof that it works is that one young girl used the template and immediately won the best prompting competition, right? Proving the point, right? So we follow the CoStar thing. What it means is start by defining the role of the agent. Summarizer, you are a reasoning model specialized in summarizing employee self-reviews for HR and engineering leadership. Do you see, guys, you're very crisp about it. Think silently. Do not reveal your reasoning, right? Why? Because if you reveal your reasoning, then people can hack it, right? Never invent achievements or numbers. Don't hallucinate, or rely only on provided text, output, blah. Then the thing is goal. Summarize engineering employees always in less number of words than the original text. Makes sense, right? The implicit to the word summarize is to use less words. Then context. You will receive a long, coherent, but verbose employee self-review. Distill it into one coherent executive summary that maximizes signal, impact, outcome, scope, metrics. See, this is important. Summarization is important, but to summarize with a constraint that you need to maximize signal, impact, outcome, scope, metric, etc., etc. These are, so guys, prompt engineering, don't trivialize it. It takes a lot of effort to create a good prompt. Learn to do that. Objective, producer, blah, this, blah, style, in what style to write, constraints and outputs, internal planning, then the do not reveal actions, initiatives, etc., etc. Right? Do not do that. So it's important to do all that.
So are we saying if you put the prompt in this format and call the LLM 2 times, it's guaranteed to return the same output?
It will give you the output that is semantically identical, but not linguistically identical. In other words, it may use different words, but it would have the same semantic content. Okay? That is it. That brings reliability to it. So guys, the first thing that strikes you is even for something so simple, most people would write a one-liner. Don't do that. Write a careful. But let's go to something a little bit more complex. Extracting achievements from a self-review. Remember, some human being has worked for a whole year or half a year, whatever, toiled like crazy, worked long hours to achieve certain things. It would be criminality to ignore some key achievements when you're extracting achievements. You cannot have a mess. You need to have a good recall. Those of you who understand precision recall would agree that you need near perfect recall, extraction of key achievements. And therefore, the prompt that you create needs to be very carefully crafted. And now you see that why prompts are not just mere English. Right? You need to craft it carefully. So here we again give. Now here you notice that because we are going to, you would agree that this is one case where you want to either use a fine-tuned reinforcement learned model, but since this is your first encounter with agents, we are not doing that. Alternative to that is something that I advise you not to do, but for now, introductory, it's okay. Use a big brain, the biggest brain you can get, isn't it? GPT-5 Pro is the biggest brain that you can get in this moment through API. So use that for the time. You're saying you are GPT-5 Pro, a reasoning model that extracts the most important achievement. So what happens is when you use the ChatGPT API, even if you give GPT-5 as the model, it may quickly respond unless you explicitly force it into the reasoning mode. You know that it's in reasoning mode when it takes a long time to answer, but there are signals. And one of the things about prompt, so there are many technical details you learn. See, prompts have problems. Research has shown that there is something called context rot. You may give a huge amount of input to the LLM. It will remember the beginning and the end much better than the middle. And there are other problems that happen, right? Lost in the middle problems and so forth. So it is a good idea to put the most important things before and in the end, right? As a bookmark. Think of it as bookmarks. You know, when you keep books, you have the two bookends. So remember the bookends matter. Right? Bookends is where you put the most important statement. elements in a prompt. So you do that. Title, you'll see that title must be 12 words, so it's concise, outcome-oriented label, etc. Context, production. I won't go into that. Guys, do you see how detailed you have to make your prompts to make it work? You have to have guardrails, do's and don'ts. Every good prompt should have guardrails, do's and don'ts, right? So when you take your kid to the zoo, you tell some do's and don'ts, right? For example, do stay near me, hold my hand. In the zoo, I would tell my daughter, right? But don't put your hand through the fence and try to pet the tiger. Isn't it? So those are basic do's and don'ts. You have to do that with the prompt. Your question.
So the system prompts are made once and then kept.
Forever. Yeah, forever. System prompts are
User
forever.
prompts you keep changing.
Yeah. User prompt is literally the user input. You have no control over it.
Oh.
Isn't it? Because what the user writes as self-review, you have no control over. Right. And so remember, system prompts there are two things that creates an agent. Well, the power of agent comes from very good prompt because that gives it the role, goal, and personality. Second is fine-tuning gives specialization. Reinforcement learning gives it specialization, and tools give it empowerment. Right? If you just remember this triad, you are on your way to creating good agents. Right? So this is it. So guys, do you notice how careful we are with the do not exceed, reliability, incidents, etc., impact area, classification guide, security? You may not have thought that to extract key achievements properly from a review, it takes so much thinking and prompt, right? And the only reason I'm trying to say, remember I said that people get angry that prompt engineers are paid a lot. Why should they be paid the same as engineers? Now you know, right? So you as engineer have to become good at prompt engineering. But then there is another thing. Prompt engineering is thinking through the best prompts. After that, and there are lots of techniques will teach you, meta prompting and so on and so forth, and reflection. You improve a prompt iteratively. You spend a whole day writing one prompt. Then what do? Then you bring in the power of mathematics. You use prompt optimization techniques to take what you consider a good prompt and make it even better, right? For that specific LLM, because you may say, hey, I'm using GPT, but then somebody will say, no, use Qwen. Then, oh my God, this prompt that I wrote worked well for GPT, but for LLM, for Qwen, it's not doing so well. What's the perfect prompt for Qwen? You don't want to keep discovering. So what you do is use what you wrote as your starting point, let the machine discover through prompt optimization the best adaptation of it for each of the LLMs that you have. Are we together? Right.
So where does the CoStar fit in? I mean, if it's going to be different for different LLMs.
Your prompts will be different. But what the thing is, you want the prompts to be different, but both these models to produce the same high quality output. The agent, whether it uses this model or this model, should produce equally good output. And so, because you change the model, its instruction set, its prompt has to change.
No, my question is, if you use CoStar as a starting point,
Yeah.
It defines a structure, right?
Yeah, and then you feed it to DSP1.
Oh,
right? That's it. So that's a technicality. When you come to the course, we'll grind you through that. Right? But for now, this is it. Now, you see, guys, like I hope this gives you a sense of how elaborate your system has to be. I won't go through the rest of the code. Yeah, go ahead.
Two questions. One, this prompt had a different template and this one is having a different template.
Yes, no, they both have CoStar, but sometimes if the job is simple, like you may not need to have too many do's and don'ts. You may omit some things. That's it.
Can we use LLMs itself to create a prompt?
Yeah, you do that. It's called meta prompting. It's one of the prompting techniques. So what happens today is you write a prompt with CoStar, then you tell the LLM that I use CoStar, find faults in it and improve it. And then it will come up with something. Then you change that, and then you go back and make it do it. That iterative cycle is called meta prompting. It's one of the prompting techniques you will learn in the course. Yeah.
I have.
Go ahead.
So in the good item section, I'm seeing some, we are hard coding some numbers, right? PS95 or.
No, yes, you do that.
Right, so that is a hard coding kind of thing,
For-
right? It is
for data.
applicable for only a particular
No,
set
no.
of candidates, right?
Thank you. Thank you. That's a very good point. You notice that in the prompt we gave metrics, etc. See, LLMs, remember, they do in context learning. So from specific examples, they generalize beyond that. So they now know what metrics look like, right? And they generalize beyond that to understand, to extract metrics from the text.
So
That's-
you mean to say that is one-shot prompting, something like that?
Yes, it's an example of a few short examples.
Yeah.
Few short examples. Very good. Yeah. So now let's look at the RAG subsystem. Oh, let's look at the MCP subsystem. This is easy, guys. Now with MCP, I'll take it. Yeah, go ahead with your question.
Yeah, just is on. Actually, we are actually using a prompt. Do you ever need to revise the prompt because the model is improving?
Oh, yes, all the time. See, what happens is that generally, so suppose you download a model, I'll say you download Llama 3.2 or something like that. Then when you fine tune it, you always maintain a validation set, evaluation set, and you check if your prompt is still good with that better model or you need to improve the prompt. So see, this world, that's why I said, right, agents and RAG, right, they are far more complex pieces of engineering than most people think. You don't learn them by reading a Medium article, right? You really have to invest a lot of energy to learn it properly. Okay, guys, so I will now talk about tools, Model Context Protocol. Now, the standardization of tools is using MCP, Anthropic's MCP. Now, here is a problem. When MCP was created as a standard, an open source project called FastMCP came out. They created the first version of FastMCP. Anthropic gave them a pat on the back and said, very good job, we'll adopt your library. They adopted the first version of the library. So if you go to the Anthropic website and learn MCP from their official documentation, you'll end up learning the older version of the FastMCP, which in my view is already too old. It's like ancient history by now, right? So use the latest version of FastMCP. This world is evolving very fast, guys. 3-4 months is like ancient history, right? It's very, very fast moving. So instead, don't use their documentation. Go to FastMCP website and pick up the documentation from there and use the latest library. It is much simpler, much cleaner, etc., as you will see. So what do? To make any function into a MCP tool, very simple. You just need to annotate it with this tool. You see this MCP tool annotation? Do you see line 42, guys?
Yes.
Take a function, annotate. It's as simple as that. It explains why MCP as a tool became a runaway success as a standard. We all know how to write functions. Therefore, we all know how to write MCP tools. Right? Easy. Did we learn something? We learned MCP. Yay! Right? So then we have, how do we create an MCP server? Oh, good grief. Very, very easy. To create an MCP server right at the beginning, somewhere at line, you will see a line of code that says MCP. Look at line 35. What is it doing? It's calling the constructor of the FastMCP. Can we do that? Does that look like a difficult line of code? No, that is it. Literally, that is it. You're done learning MCP. There's nothing else there. Well, there are things there, but not much else there. Right? So can we feel confident we know MCP now? Tools?
Absolutely.
We know tools. Okay. Let's go and do something with the tools. But remember, this is running on a server. We need to be able to call it. There has to be a client. Just like REST service, and then a REST client code that will invoke it. So we'll go into that in a moment. Let's go back to this. Let's now go into RAG. RAG is a deep rabbit hole. We gave an entire talk on RAG. Did anyone of you attend the RAG sessions? Some of you did, right? So it took 2 sessions. So RAG is another rabbit hole. We gave an entire 3.5-month boot camp on it. Sufficient is to say that RAG is a search engine with a LLM in front of it to interpret the search results and answer the user questions. Right? That's simplified view of RAG. So what do you need? Here, we are using all the project documentation is the corpus, the word people use in the linguistic space for a portfolio of documents is corpus. That's your corpus. In the corpus, we create project definitions, and I would like to show that to you. If you go to the project documentation in this directory, project documentation, you will see a file. We have simplified because it's a tutorial. We have, in reality, you'll have PDF documents, which will parse into text and so forth. We have already done that. So here is a project name, Airflow DAG Optimization. This is a typical data engineering project. Optimize core Airflow DAGs, retries, partition strategies, Presto handoff, blah, 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 right? Reducing blah to blah, blah, etc., etc. We are saying that the department that needs it is the data platform. The impact category is high. It will have high impact if this functionality gets done. Effort size is large. So what does that mean, guys? The other one was, another impact category was mission critical and effort size was extra large. So if a user comes and says that he was a lead on that project, did the whole thing, completed the whole thing, would you give that person more credits than the person who says they were lead and they finished a project of minor importance and minor effort? Obviously, that is what you want to contextualize. So these are the documents. Let's go and see how RAG is implemented. It needs a vector database. There's a whole machinery to it. And because it's not a course on RAG, I'll just assume that you'll sleep and you'll wake up in the morning and RAG would have entered your head. Right? So, but I'll show you the main code, the main part of the code, which is the actual contextualization or the projects RAG. Just look into this one file, projects RAG. Its functions, most of them are helper functions, but it should have magically one function that you care about, RAG. This RAG function takes a user query. In this case, it would be the actual achievement, right? And what it will return, a structured object made up of the things that you want.
Actually,
Namely,
under the corpus folder, you have that. I think that is what you want to show us, if under the
achievements
corpus.
evaluation.
Yeah, exactly.
Yeah, no, so first I'm showing RAG,
Okay.
that fundamentally
Okay.
RAG does this, and then I'll show the corpus evaluator. Right? So one second, where am I? Project RAG, right? So then what happens is when you go to the RAG, all symbols, how does RAG work? This is literally how RAG works. First, what it does is it takes the query through the retrieval system, gets search results, understands the search results, and produces an answer. That is RAG. Those of you who know what it means, that is what. So this is it. First, you do the search, then you get the response, then you produce, you send it to an LLM to understand it, and you get back your response. This is your basic. So this is your underlying RAG. But what is your main goal? Achievement evaluation, right? You want to take an achievement as input and come up with an evaluation of how relevant is this achievement. Contextualize this, right? So the main function here is contextualize. What is its goal? Given a list of achievements, for each achievement, it comes up with a value of the achievement, isn't it? For an HR person, isn't that the most important thing? How valuable was that achievement for the organization? Right? So that is what it tries to evaluate. So this is that. There's mechanics of it. Obviously, if you want me to walk slowly through code, we can do that, but it's 9:20. So guys, for those of you who know Python, does it all look fairly straightforward to read?
Yeah.
It's straightforward, right? You just take it, you evaluate it. The main thing is the achievement evaluation, right? That you come up with, and then you return. How did the evaluation come? Because you call the reasoning model on it. Remember, you need the big brains to do that, right? Call reasoning model. So if you go to that, call reasoning model, let's go and see what is in the reasoning model. Here, in this particular case, by the way, guys, we deliberately didn't write an elaborate prompt. So we'll let you go with this homework. While we
Actually,
created
there
good
is
prompts for
a
everybody.
more detailed prompt in that wherever we call that. This is the LLM which is ending up calling a tool, right?
That's right.
So we have a more detailed prompt. Actually, it
Oh, we
is
do have a more detail.
it is
we already
there
have it.
indirectly.
Okay.
Because this what happens is this LLM uses a tool which actually is having a, because the
I think the
we are
RAG
having
has the prompt. RAG has the prompt, and this is just the caller of the RAG. Right? Yeah. Chandra, that's what you meant, right?
yes, correct.
RAG has the, yeah, that's okay. So yes. So here we are giving a simple prompt, but if you want to externalize it and put it outside, which is a good practice, keep it externalized in a good place. Take this as a little homework to do that, to externalize it and clean it out and make it whatever. Nevertheless, what are you doing? You're giving it the context. Where is the context coming from? From the user achievement and the RAG search results. The RAG has done all the contextualization. Remember, the heavy brain lifting is there. And all you're doing is, this model returns only one thing: high impact, low impact, medium impact, one word answer. It's like the meaning of life. Come back with 42, right? That sort of thing. And it does that, right? And so, guys, this is that. Now, if we go there, you will notice that in Metamorphosis, let's go to a graph, execution graph. So this speaks to the orchestration. How are these nodes and agents talking to each other? Copy editor rationalizes the text. You agree that that is essential. Then you give it to the word cloud and the summarizer. Their jobs, those agents' jobs are done, isn't it? Then you achievement extraction is a much more complicated work. To extract the achievements, you have extraction tool, then you have some evaluator tool, how valuable it is, etc. And so what happens is, this is the signature of an agentic system, guys. Use it when you have a complex task. Did we have a complex task with many parts?
Yes.
Did it need reasoning? Right?
Yeah.
If those conditions are fulfilled, then this problem is best solved using AI agents. So it fulfills the requirements for AI agents. Does it make sense, right?
Yeah, still a lot to be
Yeah. I hope you feel that, so you come to the course.
I get it.
Yes. The TV shows do that, right? And just when the episode is about to end, they leave you with a cliffhanger.
Right.
Now you have to wait for the next episode, right? So, well, think of this as your cliffhanger, and to learn how to build these systems. And by the way, we also have physical robots in the lab. So we have small physical robots. So you will do some physical AI, right? You will have to reason. Well, our robots are simple. They are one hand and another hand. And whatever this hand does, this LLM has to reason how to learn to do the same thing with the other hand. And you will learn all of that in the agentic course. All right, guys. So, well, that is it. I'll open it up to questions. This code base is straightforward to read. I encourage you to go read it. Chandra, any particular other thing that I need to cover in the code? Agents, of course.
Yeah,
So
we
if
have
you
a
look at
LangGraph builder. Yes, under the agents.
in
And
the
self-reviewer. In the
yeah, this is it. So, guys, here's the thing: the client part of the code. How do you call this code? There is a get modifier. There are helper methods that it delegates to. Then there are agents, the agent service. You want to launch, see, the client, the UI. Did you see that we had a UI written in Streamlit? That's going to call the agentic system. So agentic system therefore needs to be exposed as a REST service. This is the REST service that it is exposed to. Most of it makes sense to you. Very straightforward. Go into the self-reviewer and look into the graph builder. When you look into the graph builder, what are we doing? Remember that graph that we show of execution with nodes? And does this code read like add nodes, add nodes, add nodes? Yeah. Right? Builder, add node, this node, what is the copy editor node, summarizer node, word cloud node, achievement extractor. Guys, does this code make total sense in view of the discussion we have been having? Okay. So actually, and this is a point I want to make, once you have thought through your agentic system At the end of the day, it doesn't matter which agentic framework you use. That choice of framework will be limited to one or two, modules. And you can easily swap from this framework to that framework because the frameworks are fast evolving and we don't know which is the winning horse. Right? A little long ago, I thought it was AutoGen. Many months I did AutoGen. Then came Creo AI, and I said, oh, it's so much better. I moved completely to Creo AI. After a little while, I realized that LangGraph seems to be gaining a lot of traction. Then I jumped into LangGraph, right? Then now, Pydantic AI is the emerging horse, is a new kid on the block. Right? This will keep on happening. Then Adno has come up, Google has come up with this agent SDK, OpenAI has come up with this SDK, Anthropic has come up with this SDK. I sometimes get the feeling that the number of agentic frameworks is exactly the same as the number of people who know AI agents. Because the moment you know it, you immediately start creating your own framework. Right? So
anybody who touched the elephant creates one
more framework based on their interpretation of what are agents. Right. So, and you can see the flavor of it. See, remember I talked about the tool maximalist perspective? Anthropic takes that. It's like lots of tools and one coordinator. And MCP fits very naturally into that perspective. Other people take different perspectives. A Creo AI takes a multi-agent system perspective, right? And you can see it in the orchestration they create. So you have to look at each of this framework and ask, see, this is why it helps. If you have the theoretical foundations behind you, you can look at a framework and you can immediately guess what was going on in the creator's mind. What is their perspective of agents? Isn't it? And that's the beauty of it. All right, guys. Yes, go ahead.
Where can we find the GitHub link?
It is very easy. You go to this website, github.com. And once you're in GitHub, you go to support vector.
I put the link in chat. Hello.
Right? And metamorphosis. Right? Yeah, look into the Zoom chat. You will find a project there called Metamorphosis. This project, support vectors, metamorphosis. So guys, please remember that. It's in your Zoom chat. And I request you one thing. If you go, you guys came through Meetup or Lumen. In Meetup, if you go, first of all, guys, if you obviously, I would have said, do join our Meetup community, but you are already part of it. If you go to About Us, way hidden under the README, we should move it up, is this thing called Server for Discussion, Discord. Join our Discord. We do follow any questions you ask, right? So suppose you forget the link to the GitHub. You can ask us there on Discord. We'll answer that for you. Are we together, guys? Right? Join that. And one final bit of request. Those of you, thank you for coming to this very interesting topic. This topic is interesting. It's always a pleasure for me to talk about it. I'm like that owl who can't stop talking in Winnie the Pooh TV show.
You can see that.
We can see that. Yes. So, well, I had fun, and I hope you also had fun and you learned something. And if you want to carry that interest further, then do please come register for our boot camps. We promise you we'll feed you well, make you gain weight, and gain some knowledge too.
Sleeping place.
And a good sleeping place. Yes. Sorry. Would you mind turning on your microphone, please? Oh, guys, one of you from the previous rows, would you hand over a microphone? Turn it on.
Can you hear me?
Yeah.
So I'm trying to figure out how can I deploy this in the server and see it in action from my own machine.
Oh, yes.
Then steps.
Yeah, we can show that to you. Chandra, would you like to show it on your computer? Share and show the steps.
Okay. Yes, sure. Right away.
Yeah, we'll do that right. Just to give you an idea, we use UV. If you're familiar with using UV, use UV, and then we'll show you the steps.
So here I have it already running. So let me kill all of them and restart from beginning. So I have my, you're seeing my screen, right?
Yes.
So.
Oh, yeah, could you
let-
please enlarge the fonts? Not
Yeah,
more.
yeah, I'm going to do that. So I have opened my project on Cursor. Okay, and so this is the same source code which Asif just showed. So here, how do I enlarge the font? Is it not visible?
Shift, yeah,
Visible.
plus.
It's okay.
Okay.
Go ahead.
Plus.
Okay, good enough. So
Bigger.
the first, once we are
One
on
step.
this folder, there are a few things we do. There is a .env.example. If I'll open it, so you will have to update it with your wherever you are downloading the code, right? You are downloading. You will have a root folder. You give the full path of the folder wherever you have downloaded this code into. Like in my case, this is my folder where I have my source code. So I have to put this here, and we repeat the same environment variable in both of these because we have some libraries which use this variable as well. So that is why we have two different variables using the same value. And then the project Python is updated, and Python path, all of them with the same project root there. And you have to update with your OpenAI API key because we are using GPT model here, which requires this key. So update it. And once you rename this to .env. So that is the first step you do. And then the next, what you do is you need to have UV installed on your system and do a UV sync. This will make sure that whatever is your PyProject.toml we have defined with a lot of dependencies, all of them get installed on your virtual environment. So this will make sure that you're able to run the code that is inside your project. Okay, so this UV
So
sync
one
will.
second. Guys, these instructions will also put it in the README of the GitHub, and you can follow along just for now. But I would strongly encourage you to use UV. UV makes a lot of headaches go away with it, right? And Chandra will now show you from that.
Yeah. So once you have done UV sync, then there are we have three again, like we will add it in the README also. But there are three main scripts to run. One is the tool server, which we have seen. So the tool server was under the Metamorphosis, MCP, and tool server. So let me run that first. UV run. Let me do it in the first because that's where I had
So
it.
while he's bringing it, guys, do you realize that tool server means it is completely separate, reusable server that anybody in the company, your organization could be using, isn't it? It's a scalable, independent deployment of tools. Yeah? It's very agentic thinking to do that.
So this tool server will bring up that MCP list of tools. So it is now, because in the code I have specified that it should run at port 3333. That is where it is running. Then open one more terminal, and in that one more terminal, I am going to run my fast API service, which is going to run the LangGraph in the background. So this is a fast API service, agent service. So this it will also internally initialize the models, the RAG, everything. It initializes all of them. And if you notice, it is opened at this location at the fast API service. I can actually go here, and this is your familiar fast API service as a REST endpoint. But we are not going to directly use the REST endpoint. We have a Streamlit UI. The Streamlit UI, I am going to bring it in yet another window. So the Streamlit, the way we start Streamlit is by doing a Streamlit run, and then the actual Streamlit code, which is under.
Guys, are you familiar with Streamlit? You all are.
Under you.
So this is Streamlit runs, basic
Yeah.
Streamlit.
So I bring this up here. So now the way the architecture is, it's this one is the UI calls the service, which is fast API service, and in the fast API service, the LangGraph internally calls the tools service, which is on MCP. So this is the whole flow. So now I can start this, and so I'm now ready to run this. So this is what we showed in another window. I had shown it where once we finished the run, this is how it came. we saw it some time back, right? I mean, I'm not going to run it again because it takes around 10 minutes to finish the whole run, because some of these go into a reasoning
thing.
model, which thinks quite a bit for achieving the extraction. So it takes 10
We
minutes.
can try that. Chandra, we can try that. Let's go and give it a lovely review. This.
Do you want to
this
change it?
time, yeah, let's say this time, I did a lot of productive work in the first 10 days, so that I relaxed the rest of the year.
What is that?
In the first 10 days, I did the work, so I relaxed for the rest of the year.
Wow. You'll be promoted.
Let's see what it says about that.
Okay.
Maybe.
I hope it doesn't fail now. Let's see.
What's the question?
How good is the feedback this for production?
This code, see, we have deliberately simplified it, but it's actually not very far from production grade code. We in our team have a pretty strong coding discipline. So you would realize that our code base is much
By
cleaner
the way,
than
while it is running, we can still watch what is happening in the background if we go into these streaming events and all that. Because LangGraph does offer that ability to return while things are happening, what exactly is happening. I mean, so that we know that it is not hanging. So that is just it's
Yeah.
for our debugging purpose.
So you will see the results. So just hang in there, and I can take questions in the meanwhile. To your question, how clean is the code base? I think once you read it, you'll realize it's pretty clean and ready for production. But we haven't put some. Say, I'll tell you what we haven't put: retries. Yeah, retries are there in a few places. Logging needs to be more comprehensive. The reason we didn't put it is when you're teaching people, logging becomes clutter. You realize that, right? Exception handling is there though. Our code is also very idiomatic Python. We don't write junk Python. We have very strong set of rules that we adhere to, and they are enforced.
What is scalability? Like, is it scalable?
Yes, like the way. So here's what I would advise. At this moment, we just brought up the fast MCP server as a standalone. Don't do that. To make it scalable, all you have to do is put it on a Ray server. Right. The moment you put it on a Ray server, you get reliability, scalability, elasticity, everything. Right. And it's just a few more lines, but because we didn't want to bring in the complication of a Ray server here, so that last
Nothing.
mile.
It found nothing, no achievements.
Yeah.
Relax. Relaxed.
So completed significant. Then so yes, so I mean, this is being very euphemistic.
And so now look at the proposal it's giving to this thing. There were too few achievements found. Elaborate on the details and add measurable achievements and try again.
I like that word cloud.
And look at the quality of the review.
Yeah.
Self-review, right? So anyway, guys, this is real code, right? It's not just smoke and mirrors. You can use it and take it to production. Just do the extra mile. See, there's a difference when you teach people. You don't want to give retries and lots of logging statements. But other than that, the code base is very clean and ready. Yeah.
Is it possible to again add the GitHub link in the Zoom chat?
Oh yeah, please. One of you, please re-add the GitHub link to the Zoom chat.
Sure, I'm doing it.
Just look for support vector / metamorphosis. Go ahead.
It's already there.
Guys, 1 second. He's asking a question. Go ahead.
So in the course, you also teach about how do you architect this, because
Absolutely.
I saw the code, it's very well structured, it's very well written. I'm not a very senior developer right now, so I can kind of relate that I have to still upgrade to that level of coding.
That is right. See, that is what we are for. We are the bridge from novice to the top 1%. I mean it. We will take you will form teams, you'll think about it, you'll make proposals. This is how it will be. Then we'll give you system architecture guidance. All of those things come with the flow. And we mean it. You can't become top 1% as we want to make you, unless you know how to do all of this. People from here are leading Gen AI teams in Fortune 100 companies. And that level of excellence comes because we have a pretty rigorous program.
One question. So we have classes on Sunday and then the Wednesday.
Wednesday.
Can we come some other time also?
Of course, this place stays open all afternoon onwards. People are here all the time. I mean, these rooms will become your second homes.
I can work from here.
Sunday and Tuesday, right?
Sunday and Tuesday, yes. You can do that. See, people do that. Once they form little teams, and you can be a solo, lone wolf, or you can form a team of 2, 3, not more than 4. People hang out. In fact, the friendships last a long time. One of the advantages is you will realize that most people, when they look for jobs, they either get a job right here in the class itself, because there'll be senior leadership here, and they will be making job offers to they will be looking, oh my God, this kid is really bright, because you'll be making your presentation. You realize that without knowing it, you are presenting to your potential employers, right? You get picked up in the class itself. And not only that, the alumni community is very strong here at Support Vector. So people help each other with jobs a lot.
Adding to the question, like you'll be teaching about the architecture, but how about one of the things you mentioned, like the Ray server. I am new to this, so I don't understand all those things, like where to deploy or how to improve the scalability. Do you teach all those things also?
See, a little bit, we get you started. Okay. We will get you started on a need to do basis. None of these things are hard. If the problem is when you try to learn them on your own, the documentation looks vast. You should learn everything in the context of a project, then it becomes easier. And we get you started with all of this. Yes.
Do we require the RAG system before we take the agent course, or we can manage?
No, it's a chicken and egg situation. If you take the agent course, we'll say you need to know some RAG. You come to the RAG course, we'll say you need to know agents.
Yeah, okay.
So the point is, people actually take the large language models bootcamp. If you really want to go the right way, if you have the luxury of time, take the large language models bootcamp along with the foundations. And again, just to show you what I mean, if you have the luxury of time, take these 2 courses first. It will really lay the foundation. It will teach you a bit of RAG, bit of agent, bit of document AI, everything. Then when you specialize into the agent course and you specialize into the RAG course, where we go really deep, we really mean it. We want to put you in the top few persons in the field, right? Then you don't feel lost, like you really have momentum. But now there are people who need to do, if you're really working on an agent project or likely to work on it, then you better start with agent right away. You will struggle a little bit with the RAG part, and our TAs, remember, you're not alone. There are TAs supporting you. They're carrying you forward, right? You have a lot of tailwind. See, let me give you a contrast. And Samantha, could you please stop the recording?